Okay, let's talk about Pascal principle. Now, the first part that we learned in pressure is definitely the general pressure, which is no longer in your syllabus, but I refreshed it with you guys. So for general pressure, we talk about the formula for pressure, which is pressure is force over area. All right. Then getting into Form 5 syllabus, we talk about pressure in liquid. And then after that, the formula for pressure in liquid is rho GH. All right, whereby H stands for depth. Apa ini? Okay. I didn't even notice you guys wrote something in the chat. Okay, then after that, pressure in liquid, we talk about atmospheric pressure. Okay, atmospheric pressure, again, we were using the apparatus that we use is actually mercury barometer. Then we talk about gas pressure. And gas pressure, we actually use manometer. And that's the Chiron, that's the reason why he's not here, is it? And number 5, hey, can you focus? All right. And number 5, what we're going to go into is actually Pascal principle right now. And for your information, Pascal principle, I didn't really memorize Pascal principle. Principle. Okay. I actually use a little bit of the previous subtopics for me to memorize. So Pascal principle, which we are going to go into right now, and obviously these are the ones that's coming up for until your exams. For Pascal principle, you have to understand a few things. Number 1, you have to understand which obviously is the concept lah. All right. Pascal principle, obviously you need to understand the concept. All right. And from the concept, there are 2 things as usual. Okay. One is actually calculation questions. And the other one is mainly on application. Application memang tak boleh lari lah from SPM. All right, so calculation part, actually for Pascal principle, there's 2 formulas for calculation. One is using the general formula for pressure, all right, and the other one is actually talking about volume. So one is actually talking about pressure for the calculation for Pascal principle. The other one is actually talking about volume. So I'm going to focus on this in the first part of the lesson. And then after that, we're going to talk about applications. For Pascal principle, the applications is mainly on hydraulic system. All right. The hydraulic system whereby you also need to know regarding the hydraulic fluid. All right, so Pascal principle, the percentage for these 2 calculation and application comes out usually is 50-50. All right, so that's why both also we have to consider lah. So let's start with Pascal principle. I'm going to be using the textbook over here. Alamak, ini bukan textbook. Mana textbook? Okay, so I'm going to go straight forward already. Pascal principle is actually in this case. All right, so for Pascal principle, the definition is actually stated at page 60 at the bottom part here. Pascal principle states that the pressure applied on an enclosed fluid is transmitted equally in all directions of the fluid. So what does this actually means? What does the statement of Pascal principle actually means? It means that, let's just say, if I have a container, I'm going to talk about piston. All right, so if I have a piston and then I can press the piston now, it's something similar to a syringe. All right, so, and this is actually fully filled with liquid. All right, all of this is actually fully filled with liquid. So I'm going to put this in blue. Okay. So if I exert a force and I press the piston down, piston is this thing, okay? This particular part is actually called piston. So when I exert a force, this is a cross-sectional area. All right, it has an area here. All right. So when a force is exerted on an area, it will create pressure. So pressure, that's where the general formula for pressure is pressure equals to force over area. Area is actually being produced. So this area that is, pressure is being produced when a force is exerted on a certain area. Pressure is actually being produced. So this pressure is actually created here, and it will be transmitted equally throughout the whole entire enclosed fluid. Main reason is actually because the water is actually trying to see where else can they move the whole entire container. So pressure is actually being transmitted equally throughout the whole entire container. So for Pascal principle, it is very, very important that when force is being exerted, it has to be an enclosed fluid. Enclosed fluid means it's a closed container. All right. Why they cannot just use the word a closed container, I have no idea. They want to sound more scientific. They want to sound more smarter a bit. I have no idea. Okay. So that's actually what it meant by this. All right. Pascal principles state that pressure applied in an enclosed fluid is transmitted uniformly in all direction of the fluid. Now you would notice actually one thing, that they are using the word fluid here and not the word liquid. Main reason is you have to understand that in the next few laws, all right, the word fluid actually consists of a few things. Now, let's talk about matter generally. We have three categories of matter that we learn in science, SPM level. We have solid, liquid, and gas. And you will notice that Pascal principle actually uses the word fluid and not liquid, is because fluid is actually matter that can flow. All right, fluid is actually matter that can flow. That's from my understanding. So liquid and gas can flow. Therefore, liquid and gas are actually fluid. All right. So does this mean that Pascal principle is applicable for gas, for vapor? Yes, it does, as long as it's an enclosed fluid. For example, even a balloon. All right. If it's a balloon, it's in an enclosed system. All right, that the air cannot goes out, and if you exert a force onto a certain area, pressure is actually transmitted equally. But for Pascal principle SPM, we usually focus more on liquid. All right, we focus more on liquid because gas can be compressed. All right, gas is compressible, but liquid not so compressible. All right, obviously the most cannot be compressed is actually solid, but comparing fluid, which is liquid, and gas, liquid is more incompressible compared to gas. Okay, so that's the reason why in the next few applications of pressure, you keep seeing the word fluid here. Excuse me. Okay, so regarding this application, if we have a chance when we go back to school on Monday and Tuesday, gamma and omega, please do let me know, because this Pascal piston is actually already at the side of the table already. Alpha already seen it, so I'm gonna show it to you guys later on and in school, okay? All right, so next, that is the definition for Pascal principle. Next, we're going to go into the concept part. All right, first part that we're going to go into is actually the calculation. All right, hydraulic system. Pascal principle and hydraulic system are closely related. Hydraulic system is using Pascal principle as a base. Okay, I repeat, hydraulic system actually uses Pascal principle as a base. So according to Pascal principle, pressure applied on the surface of the liquid is transmitted equally throughout the liquid. So if the liquid is transferred to a larger area, What does it mean? It means, like, for example, this situation. Okay, if the force is exerted onto a piston with a cross-sectional area A, it will create pressure. And when it creates pressure, the pressure will actually move throughout the whole entire the enclosed fluid. And when it reaches a larger area, it can actually push the piston up. All right. Main reason because pressure of a fluid, their main purpose is actually to see where can they push the area. All right. So that their pressure can be reduced in a way. Okay. So that's the reason why when we actually press down this part, all right, the other side will actually come out. I kind of think that I'm talking gibberish on my own. All right, so wait, something similar to this. Please kindly don't scan the QR code. I have no idea what QR code is that. Okay, now let's have a look over here. So if there is no one here, all right, just take a look over here. There's no one on this particular left side. This is a smaller cross-sectional area, and this is actually the car. Let me get up my writer. Tak ada. Okay. I'm malas on sign in. So you see, when I actually press and when I actually put a person up here, observe the position of the car. All right. So I'm gonna add one person there. Nothing happens. Add 2%. But if you will notice one thing, when there's 2% on the left hand side, there is that's a very dangerous thing to do in nowadays. Okay. According to Darius, the QR code is the simulator. Okay, fine. If you want the simulation, that's one very seriously dangerous thing. So I'm gonna tell you one thing, Darius, don't study and don't get A plus. So that's what you're gonna do, right, Darius? Please kindly don't get A plus for physics. All right. Because nowadays, this is actually a free site. All right. If you want to get the link, please kindly get it from me. This is a free site, means that at the site of these simulations, usually they will have some free advertisement or whatsoever. Sometimes it might be a virus or a bug. So if you actually scan and you open it, virus and bug can actually enter your computer or your handphones. All right. So Darius, whenever your teacher asks you not to do so, please kindly don't do so. Not because of curiosity or whatsoever. If you want a simulation, I can just send it to you guys. All right. Okay. Now, let's have a look over here. Don't sorry me if it's a virus or whatsoever. Darius is sorry your mom and your dad for trying to clear off the virus later on. Okay, so if you notice that when there's 2% here, all right, the car's location, what you can see is actually here. I'm gonna bring this up to no person again. All right, look at this area. Are you? All right, so look at this particular part. It doesn't actually reaches the top part of the bridge or whatsoever. But when I add 1%, 2%, it actually managed to push it up. So 2% can actually leave the car due to hydraulic system. I repeat, 2% with this mass ratio and this area ratio, it can actually lift the car up. Okay, so that is actually what Pascal principle is actually talking about, whereby when there is a force, all right, 2% means that there's going to be weight. The weight exerted on the cross-sectional area, it will create pressure in the fluid, and you notice that this is a compressed fluid, an enclosed fluid. So if it's an enclosed fluid, means that the pressure is being transmitted equally. The pressure that is exerted, that is felt at the left-hand side, will also be the same amount of pressure being felt by the right-hand side. So are you question, if fluid decrease, will there be any difference? Fluid as in what kind of fluid decrease? Are you give me a physical quantity in terms of what decrease? Because fluid can be density, it can be volume. All right. So what physical quantity are you trying to tell me? Could it be volume? Volume. Okay. If the volume decrease and it's still in an enclosed fluid, no. All right. There won't be any difference. All right. Because the formula for pressure for Pascal principle actually uses general formula for pressure, which is pressure equals to force over area. So in terms of the general formula, no, the volume does not affect anything. Okay, so the volume, there will be no difference lah. Okay, in terms of the volume, if it's still an enclosed fluid. But we're going to talk about the volume later on, all right, and then shortly. Okay, I hope my head is already in tune, in sync already. Okay, so force as a hydraulic system as a force multiplier. So we're going to focus on that part of the formula first. The basic structure of hydraulic system, or the basic application or concept, basic concept of Pascal principle is actually this page. All right, a hydraulic system is a system that uses liquid to transmit pressure. All right, so I hope you guys highlight this in your textbook. All right, hydraulic system is a system that uses liquid to transmit pressure. All right, so a hydraulic system in activity 2.7 shows that a force acting on a small piston can produce a larger force on the larger piston. That's the reason why for this simulation, two person can actually lift the car. A small force exerted on the smaller piston can actually create a larger force on the right piston, all right, the bigger piston. So this actually shows that a hydraulic system is not only transmit pressure, but it is also a force multiplier. So how do we know it's a force multiplier? It's based on this system. So here, number one, all right, a force. Now, when we talk about piston, all right, there is definitely two sides to it. One is actually the input piston, all right, or normally we will consider it as the primary, no, not really primary. We will normally label it as one. We will normally label it as one. And then for output, all right, for output piston, usually output means secondary, and usually we will label it as two, or sometimes they actually use the word load. All right, sometimes they actually use the word load, L-O-A-D. And over here, load can actually be a car, it can actually be machine, all right, machinery whereby they want to lift stuff. Do you still remember that over the previous holidays, I actually took a video of the crane, right, where the crane is actually trying to lift up some concrete. So that is actually considered as a load as well. And that crane is also an example of Pascal principle because they uses the hydraulic system. Okay. All right, so let's get back to this application. The first thing first is actually number one over here. You have to remember that the input are usually the smaller piston. Sometimes they also call it as a slave piston. This is actually the master piston. And then by the output part, normally they call it the slave piston. Master because it controls, all right. Slave obviously because that's the one that has to do work. Okay, so when the force is actually being exerted, and this force at the input is usually a smaller force, and the cross-sectional area is actually much more smaller. All right. So that's input. Okay, so please remember input usually we label number one, it could be called the master piston. Usually the area and also the force is actually much more smaller. So a force is actually applied on piston A1. All right, this cross-sectional area of A1 actually will produce a pressure. All right, at the input piston, right, pressure P1 is being produced on the liquid surface of A1. So the pressure is then transmitted uniformly throughout the whole entire hydraulic fluid. So this is where the pressure is going to be the same. And when this happens, okay, I a bit want to change this to. I'm so sorry. My head is really in a mess today. Okay, so when a force is exerted onto a cross-sectional area, A1, it will actually create a pressure, P1. And this pressure will actually be transmitted equally. So here is actually where P1 is being produced. And according to Pascal principle, the pressure is actually transmitted uniformly throughout the hydraulic system. So it will actually move towards this area too. So when the cross-sectional area 2 is applied with a force, pressure, all right, is applied with a force, that is where force is actually being produced. Okay, this pressure at 2, P2 multiplied by the cross-sectional A2 will become the F2. F2 is usually the load. It will actually cause the outer piston to be actually moved up. So over here, P2 and P1, they are actually the same pressure due to Pascal principle. So due to Pascal principle, P1 is equals to P2. All right, when P1 equals to P2, force of 1, which is the input, over area 1 will be equals to force of 2 over area 2. All right, so this is the first formula for Pascal principle. Okay, P1 equals to P2. So for me, as I previously mentioned, I don't go and memorize another formula for Pascal principle. I just remember that Pascal principle, the pressure is transmitted uniformly. Pressure transmitted uniformly means that the pressure at the first piston and the pressure at the second piston is the same because it's being transmitted uniformly. So P1 equals to P2, and take back the general formula for pressure, which is force over area. All right, so this is actually how I recall the first formula for pressure. Okay, so I hope that is okay with you guys. Next, I'm going to be using the same picture again. Okay, so when I use the same picture again, that is where I need to crop things out a bit. Now, let's look back to here. Okay, so obviously the first one, Pascal principle, is P1, pressure at the first piston and pressure at the second piston is the same because it's transmitted equally. So F1 over A1 equals to F2 over A2. Now let's go to the question that IU is actually talking about, asking just now. What happens to the volume? All right, so when I actually press this force down at a small cross-sectional area, all right, this liquid is actually fully enclosed. Fully enclosed means, let's just say the total volume of the fluid is 100 ml. Now 100 ml seems very liter. 100 liter, for example. Okay, if I take the force F1 pressing down at A1, and the volume that went down on the first piston is actually 10 liter. Question, where did 10 liter go? Try to answer me in the chat box. Where did this 10 liter go to? I repeat, the total volume of the whole entire system is actually 100 liter. So F1 pressed down at area A1, it actually pressed down 10 liter. So where did this 10 liter go to? The 10 liter will actually flow to the other side. And when it flows to the other side, this piston of A2 can be moved. So it will actually push up with a volume of 10 liter. Can you see where is it going? When you press down over here, the liquid will actually move towards the right-hand side, pushing it upwards by 10 liter. So in another words to say, the second part of Pascal principles formula is volume at the first piston is equals to the volume at the second piston. Okay, I repeat, the first formula is actually pressure, which I already explained just now. The second one is whereby when you press down the volume by 10 liter on the left-hand side, the volume of liquid, the hydraulic fluid, will actually move towards the other side and pushing it up by the same amount of volume because the volume got no other place to go. All right. So if got no other place to go, volume of V1 is equal to volume of V2. Okay. And this is usually we use a cylindrical hose or cylindrical tube or something like that. So usually a volume, in order to calculate volume, is actually going to be area multiplied by the depth because it's going downwards, right? All right. So that's A1 equals to D1, A1 D1 equals to area 2 and the depth of 2. You can actually use H. It's okay. Either one of it should be okay. Should be fine. All right. Just remember that this is the two formulas for Pascal principle. All right. Not one only. There are two formulas for Pascal principle. Student always forget the second one. Okay. So I hope this one you guys can be clear with that. All right. I'm giving you guys 5 seconds. If you want to copy this down, better copy before I change slides. What is D? Okay. Are you asked what is D? Sorry. So D is actually because volume, usually in order to calculate volume, is actually, let's just say this volume is 10 liter. So in order to calculate volume, we have to calculate the area. Pascal's date is finally here. So volume, usually in order to calculate volume, is actually the area multiplied by the height. So over here, the formula that they use is actually D. All right. So D to represents the depth, I think. So volume is area multiplied by depth. That's how we usually calculate volume, isn't it? All right. So I hope this is clear. Are you clear? All right. Good. Okay. So what is the force multiplier? So if you can see inside the textbook, all right, so this is actually what I've already calculated. Now, force multiplier, let's focus on this bottom part. In a hydraulic system, all right, hydraulic system is actually a force multiplier. So when the value of the surface area A2 is greater than the surface area of A1, the force on the piston is greater. Okay, so in other words to say, the force multiplier is actually the ratio of the area. I repeat, the force multiplier is actually the ratio of the area. So let's go back to PowerPoint for a while. And let's talk about the first formula of pressure. First formula of pressure, first formula of Pascal, it will be pressure at the first piston equals to the pressure at second piston. All right, because pressure is transmitted uniformly throughout the whole enclosed fluid. So okay, so over here we have force on area, force 1 at piston 1, area 1 equals to force 2 over area 2. Now, usually what we want to do is we want to know what is force 2, all right? What's the amount of load that we can actually lift up? So rearranging this formula, I get F2 over F1 equals to, let's see, F2, A2 over A1. Okay, so I want to get F2. So usually it's A2 over A1 multiplied by F1. Okay, so what is a force multiplier here? The ratio of the area is actually the force multiplier. Okay, so the ratio of area from the second piston to the first piston are usually the force multiplier. I don't really go and memorize this because usually I would just derive this thing out and then find this ratio, all right, to be the force multiplier. All right, depends on you. If you want to memorize, go ahead. But I'm very scared later they ask for force F1. So if it's force F1, then you have to flip this around. All right, so that's the reason why I don't really memorize it. I already memorized the general formula for pressure, so I'll just derive this out usually. Okay, so I hope that's okay with you guys. So that's why I say the value of the multiplying factor is actually A2 over A1. It's the ratio of the area. All right. Okay, so this one is going to applications. So I'm going to go to this other slide here because I want to explain a few things, which is actually the hydraulic fluid. It's not being mentioned inside your textbook, is it? Yeah, they don't mention it in the textbook. How tricky. Okay. Again, these slides I've already sent it to all of you inside the Telegram group before. All right, just go and find out the resources. It's at forces and pressure. So let's talk about the hydraulic fluid. In order for the hydraulic system to be applicable, usually the fluid that we use must be an incompressible fluid. Incompressible fluid means that you cannot compress the fluid any further. Water is a compressible fluid. All right, I repeat, water is a compressible fluid. If you were to take, the syringe that we usually feed the pets or we feed the kids, all right, I'm sure no one uses syringe to eat medicine already, right? So, the syringe that we actually use to feed kids or the pets, for example, if you were to put water inside there and you put stop the opening part and you try to press the piston down, all right, so usually you still can press it if it's water, because why? Water is compressible. What happens is because if let's just say, all right, if there's a piston, okay, I'm sorry, if there's a syringe, and then usually we have the piston located here. Okay, so if we were to close this part up, all right, this is already closed. All right, this is actually the piston. Okay, so if again this is liquid inside, if this is water, okay, but the thing regarding water is that water is a compressible fluid whereby water usually have air bubbles. All right, usually water has air bubbles inside that. So when the piston exerts a force F1 on the cross-sectional A1, we know that pressure will actually be created. But what happens if when you use water and this pressure P is supposed to be transmitted equally throughout all the place until it reaches this external part. But when there is air inside there, what happened is that the pressure exerted will actually be used to make these air bubbles go smaller. All right. So incompressible means that there is no air bubbles inside. All right, there's no existence of air bubbles inside. But if usually when we use water, right, water actually has tiny, tiny small bits of air bubbles inside there. So when you exert a force onto a cross-sectional area, pressure needs to be transmitted equally. So when there is air bubbles inside there, the pressure and the force is actually used to compress the air bubbles to make it smaller. So that way, the hydraulic system is no longer efficient. Why? Because it's being used to compress the bubbles, air bubbles inside the hydraulic system itself. All right, so that's the reason why it needs to be an incompressible fluid throughout the hydraulic system. And that's the reason why usually like for cars or those chair that you can actually lift up and down, they usually use oil. All right, because oil is incompressible. And then the volume throughout the input system must be the same. All right, this one I mentioned already previously. Okay, hydraulic fluid. So these are the four characteristics of hydraulic fluid. So I'm gonna explain this to you guys first, then only you all copy down. Okay, number one, hydraulic fluid is actually the fluid that's inside the hydraulic system. It must not contain any air bubbles because the existence of air bubbles will reduce the efficiency of the system. As part of the applicable force will be used up to compress the air bubbles. So the hydraulic fluid must not have air bubbles. Incompressible, all right, so that the force, incompressible means it's more towards the molecular structure of the liquid So if the liquid spacing between the molecules are actually quite further apart, when you press, the force and the pressure is actually used to compress them even further. All right. So incompressible fluid, the explanation is so that the applied force will not be used. Right, the applied force will not be used to compress the fluid further. All right, so that's incompressible fluid. Water is an example of a compressible fluid. Non-corrosive. Now, corrosive actually means menghakis in BM. It non-corrosive usually is because, let's just say, if sometimes if it's an acidic liquid, all right, acidic liquid, when it's actually interacting with metal, it actually corrodes the metal. All right, so hydraulic fluid cannot be a corrosive fluid, so that it will not corrode the metal structure, or it will not corrode the wall of the container. So this one is more general. Okay, so it will not corrode the walls of the container. All right, and lastly, high boiling point. Okay, can you all recall back what is the meaning of boiling point? What's the concept behind boiling point? What is the concept behind boiling point? Type your answer inside the chat box, please. How much heat energy needed to change state when liquid turns to gas completely? Ian, please kindly revise uh your statement is more on latent heat. Okay, not boiling point. Almost there, but a bit kelangkabut. Okay, so Hua Yang's answer is actually correct. Xu Yang's answer is also correct. It's the temperature needed to change from liquid to gas. All right, so a hydraulic fluid needs to have a high boiling point. Main reason is so that it does not become vapor easily. All right, the main reason for the hydraulic fluid to have high boiling point is so that it does not changes from liquid to gas easily, or does not vaporize easily. All right, so that's the main reason for boiling point. Okay, so there are some students who actually asked me previously, wouldn't high boiling point means that it's going to boil at a higher temperature? Yes, it does boils at a higher temperature, but the thing is that when it boils at a higher temperature means that it will absorb a lot of heat, but it doesn't boil. All right, that's the meaning of high boiling point. It will absorb a lot of heat, but it doesn't boil easily, and it won't become gas. You try to imagine if our car uses a hydraulic fluid with low boiling point. Let's just say 150 degrees Celsius. The whole entire car will burn up already, actually. All right. Main reason why, because the engine of the car actually has very high temperature. When the whole entire mechanical system actually runs, it has a higher temperature. So when it has a higher temperature, it will release a lot of heat. So the heat will actually go to the hydraulic fluid, because the hydraulic fluid is just directly underneath the engine only. It's surrounding the engine, so they will absorb the heat energy a lot. And if it has a low boiling point, then the whole entire car will start boiling, and then you'll start seeing vapor coming out. All right, so that is a seriously, you don't want to be in a car that actually start giving out vapor all the time. All right, okay, so this is actually the 4 characteristic of a hydraulic fluid. So I hope you guys are writing this down. I'm giving you guys 5 seconds before I change to the next part. Xuyang asked, does low density counts as a characteristic of a hydraulic fluid? No, Xuyang, we won't talk about density when we talk about the hydraulic fluid because low density means lower mass, higher volume. We're gonna use a lot of volume, so it wouldn't be that much related of why a low density fluid is being used in a hydraulic fluid, because a hydraulic fluid mainly is to do work. So if it's a low density material, then its ability to do work, it's not really related that much. All right, because hydraulic fluid is part of hydraulic system, which is actually using Pascal principle. Pascal principle has nothing to do with density. All right, so low density should not be counted for the hydraulic fluid. For Ian, incompressible. So Ian, I tak faham your sentence. Incompressible, so that the applied. Oh, okay. Boss, thank you. All right, so can I proceed? All right, welcome. Okay, so that is actually in terms of calculation. Now, I'm going to show you guys the calculation, then we will take a quick break. Um, let me show you this calculation. Okay, so this is actually a hydraulic system that has a small and large radar. Let me see if your textbook got any other question that I can use. Okay, I'm going to use back mine first. All right. A figure shows a basic hydraulic system has a small and large piston with a cross-sectional area of 0.05 meter square and 0.1 meter square respectively. So please do take note, if they actually use like this, they mention small and large piston, then they mention the values, and they said respectively actually means that this one corresponds to the small piston, 0.1 corresponds to the larger piston. And then a force of 20 Newton is applied to the small piston. So I'm going to use F1 for the smaller piston. The load will be F2. All right. So writing down all the values to make sure that they're all in the SI unit. So we have force 1, 20 Newton. Area 1, 0.005 meter square. Area 2, 0.1 meter square. And this case, I know that it's a Pascal principle question because it's using the word hydraulic system. All right, so that's the key word that you have to find. Seeing the word hydraulic system and seeing the word piston actually corresponds to Pascal principle because there's no other application that uses the word piston. Okay, so the question asks, what is the pressure transmitted in the hydraulic fluid? So pressure, there's two ways to calculate. Either you calculate the pressure at the small piston or you calculate the pressure at the second piston. And obviously not possible for us to calculate the second piston because we have no idea what's the mass of the load. We have no idea what's F2. So I have to use the first piston. So A equals to pressure of F1 over A1. Now, some students will ask, teacher, if I don't write the 1 over there, I write P equals to F over A, cannot. My answer is can, but try not to, because there's two areas that we're talking about. So that's the reason why I always use the subscript and I label it when I do my explanation. So force F1 is 20, A1 is 0.05. So 20 divide by 0.005. Answer is 4,000 Pascal. Okay, so that is 4,000 Pascal. Okay, so that is the pressure transmitted. Next is actually the mass of the load. In order to find the mass of the load, we know this is a Pascal principle question. So knowing that it's a Pascal principle question, B, pressure at 2 equals to pressure at 1, and we know F2 over A2 equals to P1. I'm not going to put the values in because I've already calculated here, so I can directly substitute my 4,000 over. But here there's no mass. In order to find a mass, we need to know that F2 is also equivalent to the weight of the load. To calculate the weight, it is actually mass times acceleration due to gravity. All right, so F2, I'm going to put M2G here, and I'm going to shift the A2 up. So it's going to be 4,000 multiplied by A2, which is 0.1. Excuse me. So mass M2 is 4,000 times 0.1 over 9.81. So 4,000 times 0.1 divide by 9.81. So my answer is 40.77 kg. 40.77 kg. All right, so that's my answer. This one is not applicable because this one G they use 10. All right, this is KBSM syllabus. Okay, next the question asks, if a small piston is pushed down at a depth of 0.04 meter, what is the distance moved by the piston? So you have to understand that this second part of the question, this is actually using the second formula for Pascal principle. Why? Because it mentioned that it's being pushed down D1 of a 0.04 meter. All right, and they ask how much is it being pushed up. So in order to calculate this question, C, we have to use volume. Volume 1 equals to volume 2, whereby how much is being pushed, the volume of water being pushed down, fluid being pushed down here, is equals to the volume of the liquid being pushed up at the other side, the larger piston. So area of 1, diameter, depth of 1 equals to area of 2, depth of 2. So we want to find D2. I'm going to rearrange my formula first. A1 over A2 D1. So area 1 is 0.005, area 2 is 0.1, D1 is 0.04. So here the calculator, 0.005 times 0.04 divide by 0.1. Answer is 2 times 10 to the power of -3. So the answer here is 2.0 times 10 to the power of -3 meter. You can actually give the answer like this, or you can actually change it to centimeter. That's up to you. I'll just leave my answer like this. Okay, so I'm gonna temporarily stop here. We're gonna take a quick 5 minutes rest, and then we'll come back after 5 minutes. All right. So I'm gonna leave the screen like this. All right. Those of you who wants to go and get a quick break, just go ahead. Later, if anyone, we still have 4 more minutes anyway. Later, if anyone not sleep yet within 2 hours, or I'll send a video link over. They're launching a satellite in 2 hours time, so you can actually see the launch and how they detach the fuel transporter, the fuel vehicles. All right, I'm gonna continue on. We're gonna go into the application of Pascal principle. If you notice, your textbook memang tak ada application apart of these two pictures. We have this, which is actually the car. All right, this is actually the car system. It's the braking system. It uses the hydraulic fluid. The second part of it is actually using here. All right, the jack that they lift up. All right, it's the jack that actually lifts up the cars, all right, during emergency or when they're trying to fix the tires or whatsoever. All right, so this is actually two applications of the hydraulic fluid. We're gonna go into using this slide that I have over here. All right, this is also known as the hydraulic jack. Okay, let me transfer this to PowerPoint. Still prefer transferring it to PowerPoint, so I can think wherever I want. Okay, now, so how this system actually works is that number one, we have to look into this picture first. All right, we have to look into the picture first. First thing first, this is how a hydraulic jack looks like in real life. Okay, usually what we do is actually they will usually press down this particular pivot, this particular handle, and inside here, this is actually where the hydraulic oil is actually is being located, and this is actually where the car is going to be placed on. So this is actually the load area. Okay, so this is a hydraulic jack in real life, but how does the application of Pascal principle happens in a hydraulic jack? We have to look on the right hand side picture. Now, number one, what we do is actually we have this particular handle. All right, the handle is usually being pressed up, or usually we will pump it. Okay, main reason here is that when we pump is actually to exert a force onto the piston. Okay, so and then you have the smaller piston at this area. It is actually connected to the bigger piston, which is this part. All right, and bigger piston whereby the load is located. And you would notice that there are two valves. Oh no, my color. There are actually two valves. You have valve P and valve Q. Now, valve P and valve Q will either one be open at one particular time only. All right. So what happens here is that valve Q actually allows the hydraulic fluid move from the smaller piston towards the bigger piston. And then valve P actually allows the reservoir. This is actually the additional oil being located. It will actually move into the smaller piston when valve Q is actually closed. Okay. Main reason is because every single time you press the fluid down, the fluid actually go towards the bigger piston. But if we were to pull up the handle back, wouldn't it backflow in? All right. So in order to overcome this problem, they have a reservoir which actually contains the additional fluid, and it's actually exposed to atmospheric pressure because atmospheric pressure is usually high enough already. All right, and it will actually allows the hydraulic fluid from the reservoir move into the smaller piston, and then it replenish back again. So I'm gonna use a simulation here. Uh, Darius, kindly refrain from doing anything to the if there is a QR code or whatsoever, because this one I know it's definitely open site. Okay. Okay, now so this is actually a simple hydraulic fluid. Okay, so what do we do is that usually we will press onto this lever, all right, and do take note on this two part. Okay, so what happens here is that when this lever is being pressed down, when it pressed down, they will actually create a force on this cross-sectional area, and it will press the hydraulic fluid into the bigger piston. All right. When it presses into the bigger piston, obviously one thing is that the fluid is going to move into the bigger piston because this one will stop it from coming back in. So then this will cause the fluid here to be reduced, all right, the volume to be reduced. So in order to overcome this, they have a reservoir tank here that actually allows the hydraulic fluid to fill up back the empty parts. So I'm going to show you by pressing play on this. Okay. So you see, it will open and close at the same time, at different timing. So when the lever press down, the hydraulic fluid will move from the smaller piston towards the bigger piston, whereby this valve will be open. All right. When this valve open, hydraulic fluid can enter the larger piston. And then when we want to bring it up back, when the lever wants to go back up, this level will, the top level will close so that the hydraulic fluid won't backflow back to the smaller piston. But here, the valve will open so that hydraulic fluid from the reservoir can flow back into the small piston. And that's when it goes up, the liquid will actually decrease at the reservoir. So we keep on repeating this until we manage to get the car to wherever that we want, the height that we want it to be. So if that's the case, then when will it stop? All right. Obviously, when it stops is when we actually stop pressing on this lever. And in order to move this car back down, all we have to do is open the release valve. All right. Open the release valve. Hydraulic fluid will flow back down, and the car will actually move back down. Okay. So let's see. I use this one, nothing much. Okay. So you see, this one will, okay, it's much more slower. So we actually pump it up and push the car, moving it higher. All right. When it stops, That's when the mechanics can actually do whatever they want, but please kindly don't write that in your SPM answers. And then in order to move the load back down, all you have to do is open the release valve, and the hydraulic fluid will flow back into the reservoir. All right. So this is actually how the hydraulic system or the hydraulic jack actually works. Okay. So whatever I explained just now is actually being placed over here again, but I'm going to highlight this so that you can identify the answers. All right. When a small piston is lifted, okay, the hydraulic fluid oil rushes from the reservoir through the open valve, all right, in P. So when this is lifted, that means this one goes up. When it goes up from the reservoir, it will actually rush into the small piston. Meantime, valve Q will be closed. So the cylinder connected to the small piston is actually filled with the hydraulic oil. All right, this one, please do take note. Whatever that I highlight or whatever I mentioned, please make sure that you remember this. And again, this one, I already sent it to you guys quite some time ago in the Telegram group. So when the piston is actually being pressed down, pressure is produced. This is where we have to mention Pascal principle already. Pressure is produced, is transferred onto the hydraulic oil into the big piston. At the same time, valve P closes, valve Q will open. Okay. Then when valve P closes, valve Q opens, a huge force is created depending on the area of the big piston. And the lift on the big piston exert is locked in position. This part tak payah cakap pun tak apa. Okay, so another lift from the smaller piston, another press down on the smaller piston. The bigger piston is lifted up higher and higher until the desired height is reached. So release valve is open so that the hydraulic oil from the bigger piston returns to the reservoir and the load actually comes down. All right, so if you notice, number two is where we talk about Pascal principle. Pressure is produced, is transferred onto the hydraulic oil. Okay, so that is actually where we talk about Pascal principle. But the rest of it, they will focus more on the valve, all right, and the ability for it to move the load up or to bring it back down. Okay, so that is actually for hydraulic jack. Okay, can I proceed to the next application? So I hope okay. Now, next is actually a hydraulic brake. Okay, hydraulic brake over here, this is where I mentioned about the master piston and the slave piston. Okay, so master piston is actually located at our pedal. You know, the car, when we actually drive, the pedal is actually connected to the master piston. They have special fluid over there. All right, and it is actually connected throughout the whole entire car, and this one they enlarge and focuses on the car brakes only. So this is what was being shown. Okay, so let's talk about this picture. So the brake pedal is actually where the drivers will actually place their leg on, all right, in order to press, and then it's actually pressing, creating a force on the cross-sectional area of the master cylinder or the master piston, and then it is connected throughout the whole entire car, related with the hydraulic system, and that's where we call it because in the car there are a lot of system. All right, so they call this the brake fluid instead of the hydraulic fluid in order to signifies that they are talking about the braking system. Okay, because we have the petrol, we have the braking system, and then we have the aircon pipes down there also. So there are a lot of pipes and there are a lot of systems inside the car. So they use this brake fluid and not the brake hydraulic fluid here. Okay, but it's the same thing now. Okay, so the brake fluid is actually connected to the brake pad and the brake disc. Okay, so that's actually the front of the car. At the back of the car, that's actually connected to the brake drum, the slave cylinder, and also the brake shoe. Okay, so let me go back to just now that slide. All right, here, when the hydraulic fluid is connected to the cylinder, it is actually connected to the brake shoe Okay, so a small force acting on the pedal can transmit a large force to all the wheels simultaneously to stop the car, because it is the pressure that will be transferred from the pedal of the brake liquid to the car's tire. All right, so this one is actually using the hydraulic system as well. Okay, so up to here, are you guys all right? Okay, so I'm going to talk about this application. All right, another application of the hydraulic system. If you are to ask me how many systems are there that uses the hydraulic fluid application, there is a lot of application. We have what we have the hydraulic jack. That's one of it. You have the car braking system. We have the dentist chair, dentist car. Okay. We have the crane. All right, the crane machine. That actually uses the hydraulic fluid also. All right, this is the crane machine. This actually uses the hydraulic fluid as well. Main reason why it uses the hydraulic fluid, let's see. Let me just take a simple picture. All right, why does this uses a hydraulic system as well? Because the driver that controls, they can actually move the crane either to move higher, lower, towards the left or towards the right, and all this actually uses a hydraulic system inside there. All right, obviously there's many different types of cranes. All right, to do a lot of different tasks, especially related to heavy objects. All right, main reason is because in order to build buildings or in order to build infrastructures, you need to have a lot of force in order to lift all those concretes. So the only method for them to do that is actually using the hydraulic system or the Pascal principle system. Okay, so so that's a few applications for this. Let's talk about the chair. So very quickly, because I know that we are almost done already. Okay, so let's talk about the aspects here. There are four aspects. As what Puan Liao actually says, usually this is a 10-mark question. If it's a 10-mark question, look at the characteristic that's being used. She did mention previously that we have to make sure what is the mission. So the mission here is to explain necessary modification so that the chair is safe and suitable for use of adults. Now, if you're talking about adults, you have to understand that there are multiple sizes of adults, there are multiple variation of adults. So you have to know that most important thing is the chair needs to be able to accommodate very high mass. All right, bigger size people. All right, so that is a few things that we have to consider. Higher mass, bigger size, which means the load is going to be very high. Okay, so here the size of the piston, they're talking about two piston. Then you'll be thinking there are two piston there, so what are we going to talk about the size of the piston? So because this is only four aspects that they give. Okay, size of the piston, material to house the liquid, size of the seat, and type of liquid for the jack. Okay, this is a 10-mark question. So usually 10-mark, we need 5 aspects, but they only give 4 over here. So you can expand it. All right, usually what I will expand is I will either expand the size of the pistons, whereby I can talk about 2 pistons, or I can expand talking about the 2 different types of hydraulic liquid. Okay, so here I'm going to choose to talk about the type of the liquid 2 times, 2 different aspects. So that would be easy for me to get the more scores for that. All right, so remember 10-mark question, use a table. Tapi table Y3 column. Let me erase off one. Okay, first is actually modification, and the other slide explanation. So let's talk about modification. Size of the piston. Size of the piston. What I'm gonna say is, I can say, okay, in order for the size of the piston, always remember for Pascal principle, if you want to accommodate more, the bigger piston make it bigger, the smaller piston make it smaller. Why? Because of the force multiplier. The force multiplier needs to be a higher multiplier. Higher multiplier, let's talk about force multiplier. Let's go back to force multiplier side. This is the force multiplier that we did just now. The area A1 and A2 represents the size of the piston. To be more specific, it represents the area of the piston. So if area 2 is the larger piston, all right, area 2 is the larger piston, area 1 is the larger piston, smaller piston. So if area 2 goes bigger and area 1 goes smaller, this force multiplier will increase. When the force multiplier increases, the load that we're gonna be able to carry is going to be even more. All right. I know some of you won't be able to brain that, so I'm going to use this ratio. So let's just say I take this ratio, 20-20 ratio. All right. The force multiplication here, A2 and A1 has the same size. So even if I were to increase, let's just say 20 people, then only I can balance them off. All right. So if I wanted to be able to move this load up, assuming this is the dentist chair, I want to move the person up. So I have to increase the force multiplier, which means the bigger piston has to become bigger. The master piston or the smaller, the input piston have to become even smaller. So when the input piston becomes smaller, you'll be able to lift this up easily. Or let me try to show this one. For example, 7 and 20. 7 and 20 means that 4-person cannot lift the 20, but 8-person can lift the 20. All right. I need 8-person in order to lift the car. But if I make the ratio even smaller, 3 to 2, 3 to 20. So the person that I need in order to lift the car is actually 4. Because if it's 3, still can. 2, the car will actually move back down. But if I were to use 3-person on the input piston, it will be able to lift the car up. So in another words to say, the this force multiplier need to be a bigger value, a bigger multiplication. In order for it to be a bigger multiplication, the bigger piston, the area must be bigger. The area for the small piston must be smaller. Okay, so in this case, what am I going to write my answer there? All right. Size of the piston, bigger area for big piston, smaller area for small piston. Explanation, what I mentioned just now. To have a bigger force multiplier. All right. I last year taught you guys on using logic to answer the question. But I think this year onwards, since I already learned a few methods from the other teachers while they were marking the SPM papers, it's better for us to use back the formula instead of using logical answers. All right. But if let's just say you memang cannot think already in an exam, number one, turn to page 2, look at the formulas. Is there any formulas that can help you? Number 2, if you still cannot use the formulas, cannot use the actual physics concept, then only you give logical answers. All right. But for me, try to use physics formula answers instead first. All right. Physical quantities first. Next, material. Material to house the liquid. Okay, so this is actually a dentist chair modification. This is not actually we can consider it as a dentist chair, but it doesn't need to be related to heat. So please don't say that it is heat resistant. Okay, so material to house the liquid, most important thing, it has to be strong. All right, it does not interact with the liquid that much, but try not to use into chemical terms, chemistry terms. So for me, material to house the liquid is strong material. My answer is strong material. That's in my head. So let's see. Stronger alloy. Okay, strong material lah. Okay. Strong metal. Okay. I will actually use strong metal. So reason is because this is going to be exerting force on a small cross-sectional area. It's going to have a lot of pressure. So the explanation here would be to withstand high pressure produced by the liquid. Okay, so remember, strong metal have to withstand high pressure produced by the liquid. Next is actually the size of the seed. So size of the seed, we need to accommodate higher, bigger size, bigger load. So size of the seed needs to be bigger area. Reason, okay, now we cannot say that it's going to be using for adults, so we can actually to allow, how am I going to rephrase this? To allow use of adults. Okay, I'm just going to use bigger size, bigger size. Size of the seed, bigger area to allow bigger sized people to be able to be lifted up. Okay. I'm trying to write so that it doesn't really sound so offensive. All right, next is actually the type of the liquid for the jack. Now, remember hydraulic fluid, there is 4 options. Okay, so high boiling point cannot be used over here already, mainly because this has nothing to do with heat. So what we can say is type of liquid. The first type of liquid that we can talk about is incompressible liquid. Okay, so that the force applied will not be used to compress the liquid instead. All right, the next part that we can talk about is, again, because I want to talk about the type of liquid as well. So the next type of liquid that we can talk about is non-corrosive. Non-corrosive liquid, so that the liquid does not corrode the walls of the okay, I'm going to use this. All right, so that is how I get my 10 marks, and this is should be reminding you guys on how to write a 10-mark essay questions. Please, 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 please do not give me an essay format. Don't give me a paragraph format. put it in a table. Make it a habit for you guys to put it in a table. And if you notice one thing right now, I have one modification that corresponds to one explanation. Don't write a few explanation. All right, in the exam, try to just use one. If you're gonna write two, make sure that they do not contradict the answer. All right, they don't contradict each other. Okay. Teacher can write bigger difference between the area of the no, Daniel, you have to mention what kind of bigger difference that you are talking about. You cannot just mention bigger difference like that only. Okay, so you have to mention clearly the difference that you're talking about is either bigger ratio, higher ratio between the area of the big piston and the small piston. Difference cannot. All right, unless you use the word ratio. Okay. Any other questions? No questions? If no questions, then that wraps up for our Pascal principle. So very quickly again, recalling and refreshing. Pascal principle, all right, there are two parts to it. Calculation, all right, the calculation part whereby we talk about pressure, whereby pressure P1 equals to P2. Pressure is transmitted equally. So F1 over A1 equals to F2 over A2. All right, then we have the volume in the hydraulic system fluid. Volume that is pressed down for the input piston will be the same volume of the piston that volume of the second piston that goes up. The second part is actually the application, whereby hydraulic system we uses hydraulic fluid, and we have different types of fluid. So the formula, the definition for Pascal principle is that the pressure is transmitted equally throughout the whole entire system. So for Pascal principle, a few things that you all have to take note. How do we identify a question? Number one is actually from the picture. The second one is actually the word hydraulic. All right, the second word is actually hydraulic fluid. So a hydraulic system, a hydraulic fluid, that will actually shows you the direction of Pascal principle. All right, so that wraps up for Pascal principle on Monday. Monday don't have class. On Tuesday and Wednesday, hopefully Tuesday, Wednesday tak ada benda already disturbing our classes. Tuesday and Wednesday, I will come out with probably 1 to 2 questions on essay questions. We focus on essay questions on Tuesday and also on Wednesday. All right, because then Thursday and Friday is already exam and also road run. So any questions you guys want to ask me? Thanks for joining in the class anyway. No question, ah? Okay, no question. Then we're gonna